Welcome everyone to this lecture where we are going to take a look at the code of how we can make our SSH Bruteforcer work faster by using thread library. Alright, so here is the code, and the reason why we are not going to code it ourselves is because it is rather similar to the first program that we coded in the previous few videos. There are just some minor changes as well as adding some libraries that we are going to need. So let's start off from the beginning. Well, first of all, there are two different libraries that we had to import next to these four. Those two are time library and threading library. Both of these libraries belong to the default Python libraries, so there is no need for you to actually install them in your virtual environment as they're already there. Right after it, at the beginning of the program, we declare a stop flag variable. And this variable is going to be of use to us once we get to the actual threading part. So, for now on, we simply just declare a variable and it will be an integer value of 0. In our SSH connect function, we make a few minor changes, such as, for example, we declare that we are going to use the global stop flag variable inside of this function. Then we perform the same two things that we performed in the regular Bruteforcer. After it, we try to connect, and if we manage to connect, then we set the stop flag to be equal to 1. Then after it, we print that the password was found, and in any other case, we will print incorrect login, and we will close the SSH connection. Now let's get to the part where we actually set the stop flag variable to be equal to 1. Why do we do that? Well, if we go all the way down, all of these things are the same as in the previous program. Right here, I just added a print statement that says starting threaded SSH brute force. And below there, we open the file for passwords. And if we go to the passwords.txt file, you will notice that I added a few more passwords right here, around 150. So we can see how fast it will brute force. The correct password is somewhere around here. And let's continue with the program. So we go into the for loop and we read password by password or line by line. And if stop flag is equal to 0, then we will join all threads and exit the program. And the threads that we create are actually down here. Okay, so let's not pay attention to this part of the code at the moment. So for each password, we perform the strip function onto that password so we can get rid of all the unnecessary characters. Then we create a thread object, which is going to be called T. We perform the actual thread object and the thread function onto the SSH connect function, and that is the first parameter to this thread function. So the target is the actual function that you're going to perform the thread on, and the args are the arguments to that function. So in our case, that is just one argument, which is the password parameter. And this comma right here has to be there, even though we don't have a second parameter, otherwise this will not work, so we have to add it right here. Right after we create the thread object and we call it onto the target of SSH connect with the arguments of password, then we can start that thread and we can sleep for 0.5 seconds after every time we start a thread. Alright? So what this will do is it will start the thread each time a new password is being read from the file, and each password will have its own thread. And in case the stop flag gets switched to 1, well, that means that some of those threads actually manage to find the correct password as they manage to connect to the target. Therefore, we set the flag to be equal to 1. And once the flag is set to 1, that means that we can close the program since we found the correct password. Therefore, we perform the t.join function, which will join all the threads that we're running, and then we can exit the program. And that is the entire program that runs on threads. So let's see whether it is faster than the previous one. First, I'm going to go and enlarge this. Then I will navigate to the PyCharm and then SSH brute force. And first we will run the previous program. So the previous program had no threading library. And let's see how that one will do. So the target address is 192.168.1.3 in my case. The SSH username is msfadmin. And the passwords file is password or passwords.txt. Press here enter. It will start running. We can see we got some incorrect logins. And you can see each password takes around 1 second to finish. Therefore, this is going rather slow. So let's just Control-C this so we don't wait for the correct password. And if we run the second program, which is our threaded brute forcer, and type in the same information, it will start our threaded brute forcer, and you will see that the passwords go a lot faster than before. As you can see, we already managed to cover more than 20 passwords, and here it is. Here is the correct password. And few seconds after that, it closes the program. Now the reason why it goes for few more passwords after finding the correct password is because all of these passwords were separate threads that were ran before this one has finished. Therefore, it had to finish these ones first and then exit the program. And you can see how many passwords we managed to actually cover in just a matter of a second or two, and it also managed to find the correct password. Now the reason why incorrect passwords are printed in red is because I also added a print statement somewhere around here, which says that we print the incorrect password in red color by using termColor.colored function, which we already covered before. That's basically it for this SSH brute forcer. I hope you enjoyed this section as well as the previous two. And this was also some type of a recap video to this brute forcer. Therefore, we're not going to do a recap video as a next lecture. We're going to go straight into the next project. So hope you enjoyed this one once again, and I will see you in the next tutorial. Bye.